is, in a Mac OS command line app, create the interface and implementation in two different files for a class Carnival Barker that has an instance method bark that barks and a class method remaining employed that gives the total number of Carnival Barkers that are left employed. So how can I get started? I need two different files for these things. What are those files usually called? Yep. My files are the .h header and .m objective-c files. Kimball, what goes in the header file? Okay. Let's look through the second clause of this prompt. Create the interface and implementation for a class Carnival Barker. So interface and implementation are two separate parts of how we use a class. Do you think the interface or the implementation goes in the header file? I'm going to say the opposite. So in the header, we'll have the interface, which is how a person using our code should use it. And then in the, we can get rid of these comments. So then in the objective-c file, what would go there? Anyone? Thank you. We'll have implementation. Question for the audience. What principle of object-oriented programming does this help us enforce? Hands straight up. Go for it, Sunny. So it's actually a little different. We are abstracting behavior, but using an interface and an implementation has a specific purpose. Let's grab a different one. What are some other principles of object-oriented programming? Encapsulation? Okay, tell me about encapsulation. Okay, here's a pretty good definition for encapsulation. Data is contained within objects and is not accessible in ways other than what has been defined within that object. So our interface provides encapsulation for some functionality, for some information, for the object that we're using. We do use objects for abstraction. How do we create abstraction with our code? Think about why we use objects at all. Carrie, why do you like to use objects? They do receive messages. Let's think back even to like Unit 2. Do you remember Game of Thrones? We were given a whole bunch of episodes that were in seasons, and they were all in these big arrays. What would have been an easier way to deal with that? Say I just gave you an array of objects. Is there a way that we could have used abstraction to make those objects more usable? What's that? Okay. Well, let's just think about like in human terms. If I've got a bunch of episodes, what could an episode belong to? They could belong to a class, but like just human terms. I was watching a whole bunch of episodes of this show last night. What do episodes usually occur within? A what?
A binge.
Yeah, great. How do I organize my episodes? Might be another way to ask it. Each year, a new group of episode comes out. What do we call those groups? Okay, so we might call it a season, and we might say that a season has a bunch of seasons put together are a TV show series. And we're using abstraction here to break out some basic functionality into something more human readable and even just on a more functional level to do the job of those things. Do the job that a real life object might. So this is why we have properties. This is why we have methods. And encapsulation is saying, okay, on the flip side, this can only do what I want it to do. So our interface enforces encapsulation. Our implementation provides the functionality for that encapsulation through abstraction. Great. All right, let's actually make our carnival barker. Nima. Yeah. So the way that we are encapsulating our data for other users is we have this interface. We're saying, if we look at an interface in just a moment, we're saying to whoever is using our code, hey, here's what's available to you. You don't get to look around. You don't get to say, like, I want this, I want that. Our interface says, we're exposing to you only what we want to give to you. And generally, when we're using objects, what we are encapsulating is the abstraction of some real life thing. So our methods, our properties, if we have, for example, a carnival barker, they might have some string just saved to it, but that string might be a name. There's a reason that we have that string saved there. That's a very simple example of abstraction. As we build more and more classes and more objects and have more inheritance, we'll begin to see how abstraction grows and grows and grows, and it's all very fun. But think of abstraction as you explaining a real-life object through code. Yeah. All right. I want to make my barker. How can we get started? Cool, I'd love to. How do I do that, Liana? Okay, that's a good guess. What'd you call it? Cool. So the .h implies header. And actually, we can infer that. We can assume that this is the header file just from that file extension. What goes in the header? Yep. This stuff? Yeah. What? Okay. So a header file is not unique to Objective-C. It's also used in C, C++. And so this is a generic header file. This is inserting for you some generic, I think C directives. And we don't need them, I promise. But when we're using a header file, just know this applies to multiple languages, so it tries to give you like what its most basic level is. Ah, crap. I lost my file. Header file. What's in here? The interface. Cool, let's start making an interface. How can I start making an interface? I could use my words. Cool, let's use some words like interface. I named this file Carnival Barker. Ian, what do you think I want to name this class? Hell yeah. Carnival Barker. And then the interface asks us to subclass our interface from some superclass. Have we created any other classes that we think would apply to this class? No. So what's the root or base class that we could use to make sure we've got at least some important functionality? Let's use an NS object. Just autofill for me. Okay. And again, this NS object, ooh, love it. It's a group of methods. It has the group of methods fundamental to all Objective-C objects. But interesting, it says it's a protocol. We're going to spend more time on that next week, but isn't this weird? It says it's a protocol, even though we are using it, or we say we're using it to subclass. Amazing. What does NSObject at least let us do? Say I didn't have this. Could I make any carnival barkers? Why not? I need to subclass NSObject so that I can, what? So that I can inherit what? I can inherit functionalities. And which important functionalities specifically am I getting from NSObject? Angela? Yeah. The most important are a lock and a init. Can you tell me briefly what those are? In memory. Yep. Allocates it. And you said init does what? What's that? Okay. Init just creates an instance there. In that space in memory. Something important to know is that because we are using inheritance, if there aren't any methods or properties for our subclass, it just has the methods and properties of an NSObject. That's it. We could use it exactly like an NSObject, but with nothing special going on. No. Implemented. No implemented methods or properties. We'd only be able to use the ones inherited from NSObject. Amazing. All right. So I started making an interface. The two things I want to do are have an instance method and have a class method. The instance method is called bark. Bark. And the class method is called remaining barkers. Remaining employed. It's upsetting. Okay. Jason, in the interface file, am I actually going to write the code for how these things work? Am I actually going to write the code for Bark to see how it works? What am I just going to do here? Cool. How could I type that out? Awesome. So you said using a dash at the beginning of the line indicates an instance method. Love it. All right, now I want to make this remaining employee. This might have been a little tricky. Jocelyn, how can I make a class method? Okay. How can you find it out? Yeah, let's get used to the Objective-C documentation. Amazing. Objective-C documentation class method. The class method. Uh-oh. What do you see here in this documentation about class methods that Apple's put together in their library? Well, there's a big indicator in the middle of the screen. It's deprecated. It may not represent best practices for current development. We should probably avoid using that, even though it did tell us the right answer. All right. Here's a different one that doesn't have that message.
Wouldn't it make more sense to use the other one since this one says 2014?
It would, but they're literally recommending that you not use it.
Right, but would they not recommend you use this one too since it's just as old?
No. They would explicitly tell you. Because it may be that the practices, best practices have changed in that time. It may be that this is actually a smaller set of information. There might have been more details that are incorrect in the newer version. So as things change, they will indicate to you what is best. It's not just going to be recency, especially for something, unfortunately, like Objective-C that hasn't updated in the last 6-7 years. So this is some nice stuff. That's great. I think you saw it before, so we're just going to go with your answer. But let's see if we can find the basic syntax. There we go. Properties, which we're going to talk about today. Method declarations. The method declaration looks like this. Methods can take parameters. That's great. Tell me something I want to work with. Class names must be unique. I don't care. I guess we could control F, look for a class method. Interesting. Class method. Typical use for a class method is as a factory method, which is an alternative to the object allocation and initialization procedure described in objects are created dynamically. This class has a variety of factory methods available to create either an empty string object or an object initialized with specific characters, including, interesting. So this plus sign is how we create a class method. But what are they telling us is probably the most important use for a class method? So here we're not actually going to use it on an instance, but we're going to use it for a specific reason. Think about this phrase, factory method. We've seen it once before. We talked about it in extending some basic types to give you back an instance of that object, or a set of instances of that object, when we talked about style in your code. Factory method is a method that returns an instance of that object to you with a specific format. This is like a set of custom init functions. So the most common way that we're going to use a class method is to create instances of that class. Like it says in the documentation here, it has factory methods to create either an empty string object, this first one, or an object initialized with specific characters. So a string with string creates an NS string out of an NS string. String with format creates an NS string using an NS string, of a specific format. When we talk about factory methods, we're saying here are a bunch of different ways to create an instance or a set of instances of this object. So these are just like your init functions that you're used to, but they're initializers taking in maybe a different set of information. You can create, for example, an NS number out of a float, out of an int, out of a double. Those are all factory methods. Levi.
So really, we should create a class method that gives us the number of carbon markers, meaning carbon markers should have property of number of markers, and then the class method would set that.
If only. Because we're going to see in a second, unfortunately, we can't quite do that. But yes, we should have some property available to our carnival barker, or at least the way we're used to it in Swift. There might be something that's a static variable called number of markers, and you could go and retrieve that using some function. Unfortunately, we have to do something slightly different. And so in order to have a class method, let's start with this plus sign. What is the return type of remaining employed going to be? So our signature starts with the return type, then the name, and then maybe an argument. What is the return type of remaining employed going to be? Let's make it an int. Int. Remaining employed. Awesome. Rod, is that our entire interface?
Yes.
Neat. So we're done with that .h file? Cool. Let's move on. I have my interface. I need my implementation. What kind of file should I use for that? Yep. I have a .m, but think about it just like with our models in Swift. I don't want to have my .m file hold the functionality for other kinds of things. Main.m there is just running our program. I want to separate out the functionality of a carnival barker into different places. The implementation for it should be outside of any other file. Think about it like if we had a carnival barker in Swift. We wouldn't create that struct in the same file that we're using it. Instead, it would be in its own file. So let's make a carnival barker.m file. Cool.
Just create a class, create
Yep. That's a wonderful point. If you create a Coco touch class, it creates both .m and .h. What's Coco? What's Coco touch? What? Did you say a suite? We'll get into both when we start iOS development. Amazing. With Objective-C. If you look on the calendar, it is scheduled for 2 weeks from now. Okay. All right. So we have the interface for our carnival barker. We want to make the implementation. Anthony, what's the starting point for an implementation?
You have to write an implementation.
I love it. Let's write at implementation. What don't I have to do on that first line where I see at implementation? I do have to put the name, which is not ZF or whatever. Keep going. What don't I need here that we had in the .h file?
Oh, the inheritance.
Yep, don't need to show the inheritance here. Cool. What's that? Interesting. Do we need to import the header? Why would you say that? It's saying I need a superclass. Try and import the header instead. Yes, but let's talk about why. So the header is an interface also for its implementation.
So it's kind of a protocol.
It's kind of like a protocol like we've been talking about, but it's going to communicate rather than provide a blueprint. So it's going to communicate, if we import it, that Carnival Barker is a subclass of NSObject, and the way that we actually get NSObject is we're going to import foundation, which is where it's defined. We import foundation, which is where NSObject is defined, but we also need to import the interface here so that our implementation knows it should implement Carnival Barker, and it should also interface with NSObject. Sunny?
I thought we didn't have to import foundation in that file to get the next object.
Because we actually aren't using it for anything right now. Sorry, we aren't using foundation for anything in here just yet.
Isn't that how we're getting in a subject? How does this file know there's something called in a subject that exists and is not importing?
Oh, we're going to break it first. Is that okay? All right, cool. Let's break it first. So we import foundation. We also need to know what this interface is with, or else there's no link between implementation and interface for our new class. So rule of thumb, import your interface into your implementation. Cool. Levi, how can I import my interface?
I would do it above this, all that comment about code, because I'm anal retentive.
Anal retentive. Cool.
And I would do the hashtag, which is not complicated. If it worked, open quotes.
Open
Square
quotes.
space, Carnival Barker on each.
Amazing. Any idea why you had to use open quotes?
Give you an error.
Let's use that error. Cool. Let's build this.
And it's like couldn't find it, use quotes instead.
Couldn't find with angled brackets, use quotes instead. It is talking about a file name. That's great. We need to import the header by file name because it's not a built-in package or a built-in library like Foundation is. So for your local files, local file. You have to import them explicitly by name using quotes. All right, we've got our carnival barker. Let's see if that error went away. Cool. So that error asking us to subclass this carnival barker for its implementation is now doing something similar to what we see with our protocol stubs when we try to conform to a protocol. It's saying, hey, I looked at the interface, and if you're trying to implement it, you haven't actually defined that implementation for bark and remaining employed. Adam, let's implement bark and remaining employed. Yep. So we have our instance method bark. We have our class method remaining employed. Can you speak a little louder? Let's just have bark print out whatever a barker barks. Okay. So if we look at the interface, it's going to tell us what the signature should be of those methods. Mm-hmm. So we can actually use those signatures to get started, and then it's actually just like creating the body of a function declaration in Swift. We have to write it in Objective-C, but it has the same syntax after that. All right. Is that where your carnival barker is going to bark? That's what your carnival barker is going to bark? All right. That is purely a design decision. Whatever you want to do. Cool. Now here's a question. I want to create my class method. And let's say that class method, like we set up in the interface, returns an int. And that method is called remaining employed. Try as we might. Try as we might. How could we have gotten the remaining employed? Anyone figure out a way to get that at the class level?
Really understanding what you wanted from this.
Yeah, because it's something that we haven't really seen before. This would need to count every instance of a carnival barker. Bark. What's that? It's not a pointer issue. It's more a scoping issue. How do we used to refer to all the, let's say, instances or information about a class in Swift? It's a struct or a class level. How would we get information stored on a struct's definition? What was the keyword? Think about how we defined structs. We can make instance methods. We can make some kind of other method that applies at the type level, not at the instance level. Yep. We could also have a static var. Those don't exist here. I'll take the emotion out of it. So I can't store something like, I don't know, static var number of employees or number of Barkers left, and then just have that equal 10. Can't do that. Any idea how we could keep track of that information, though? Sunny?
Create a property, class, article, Barker.
So if we create a property, those are going to apply to instances of Barkers. And I'm going to want a way to access information about all Barkers.
Should we create a different object?
We could totally create a different object. One approach. Create a different object. What would that object be called? Let's think about a pattern we've seen plenty of times in iOS development specifically, not necessarily Swift development, and we've said there are problems with using this thing. But what is a way that we've created an object that all other files can access and have access to? So not a protocol, because a protocol is just a blueprint, right? A singleton. So the reason we see singletons all the time in our iOS development is that originally those frameworks were in Objective-C, and you couldn't store information directly on a class. You couldn't have a static var. Instead, there would be a singleton for something like URL session. That would be the one URL session that everyone uses. And that specific instance would hold the properties we're looking for, would have the instance methods we're looking for. It would have all these different things. We would use a singleton to store what we call maybe global or readily needed information. So the singleton we see everywhere is kind of a relic of Objective-C development, because Objective-C needed it. There was no such thing as a static var. Most of the singletons we've been using in Swift, like URL session, we didn't necessarily need a singleton for. To make a call in a URL session, we could create a new URL session every time in our network manager. We could do all these things, but that singleton had to exist for Objective-C. So that's definitely one approach. And we are going to come back to this down the line. Another approach, just global variables. Has anyone ever created a global variable? No? Who's done it? All right. Tell me about the global variable you created. Across the application, I would create global Cool. Let's use some emojis to express ourselves. This part is good. This part is not as good. Cool. When you wanted to use a variable or a value across the application, you created a global. A global is just some information defined in the global scope. It's not held as an instance method or instance property or anything attached to an object. It feels hacky, but you can do something just like this. Int number of remaining barkers equal 0. Why am I going to get an error? They always give it away. So this int is not saved in Carnival Barker. It's only available in, at this point, the global scope. We'll see just how it's actually scoped when we go to use a Carnival Barker. But later, when we have init functions, we can add new hires to this global variable.
What all hires?
New hires. So again, talking about abstraction, if we created a new Carnival Barker, let's say that's hiring someone new, and that's increasing the number of remaining barkers. Cool. So our barker barks, and then knowing what I know now, how can I use this class level function to return an int that tells the user the number of remaining employed barkers? Yeah. So I've actually got some information to reference now. This global var, sorry. Oh, okay. I can just return it. That's what we're going to do. I'd love to. So just to get this number of remaining barkers, all I gotta do is reference that variable. And this is pretty dry, right? It's one line, it's just doing what it's supposed to. Let's get this error to go away, thank you. So our class variable is just reading off some global. I can't read off a static var, static vars don't exist. Just gonna read a global. Cool, that's great. Let's see if we can use our Carnival Barker. The implementation imports the header, which tells it its interface. It also imports Foundation. If I wanted to use anything from Foundation, like, I don't know, nslog, I can now use it. I use quotes for Carnival Barker because it's a local file, whereas Foundation is a package available to me, a library available to me. And then in the .h file, I've got the interface. Let's see if I can just use this thing. In my main function, let's make it Barker, which is a Carnival Barker. Why is it not lighting up? Yeah, I can't get a Carnival Barker until I import it. This is another .m file. This is another file within our project. If I want to be passing around functionality, I gotta import it. So this is the really fun part of Objective-C. If we want to share functionality, we have to import that functionality. Now here's the 13-cent question. In this file, do I import the header for my Barker or the objective C. C file. Thanks, Levi. Aaron, I just created this class with an interface and an implementation, and now I want to import it so I can actually use it. Do I import its header, or do I import the .m, the objective-C file? Why do you say that?
You want to do that. I'm not sure.
Okay, let's try it out.
Objective-C file sounds like right.
Okay. Carnival Barker, let's say allocate, let's say init. Now, if I want to say Barker dot bark, let's see what happens. Adam. What? Well, force of habit, but also we're going to be creating our own custom init functions, and we're going to want to be able to call init specifically in that space. Property access result unused. Getter should not be used for side effects. What the hell does that mean?
Shouldn't you write it differently?
Interesting.
Sending a message back in.
So I can't use this dot notation. Damn. Notation for my methods because I'm really sending a message. Bad. Okay, how do I do it? Rod.
No, wait, I have a question.
Okay, Rod's question.
Why isn't even letting you do the dot thing if it doesn't work?
We're going to see that with properties. So it's trying to read it in one way that's actually not available to it. And it's not going to know that right now.
Okay.
But now I want to send a message. Can you send a message with me?
Do the brackets.
Cool.
Barker, and then
What do we want it to do?
bark.
Cool. We're telling the object what to do. We are sending a message. We're interfacing with it. Now let's run this. Ah, man, it's failing. Why is it failing? What does that mean? 3 duplicate symbols for architecture, x86, 64. Who wants to get into architecture right now? No? Okay, cool. So we have to import the header file. And let's not worry about why that was the issue. But let's just make another rule for ourselves. Rule, import the header to share functionality to interface with the rest of the files. S. Cool. We did it. We made a thing. What? Oh, it ran. Check this out. Bark. Isn't that cool? You have an error? Damn. Sounds like a you problem.
David!
Well, before we go anywhere further, how can I actually call that class function? Sunny?
Send a message to Carnival.
That's right. I'm going to send a message to Carnival Barker. Forgot what it's called. Remaining employed. Cool. So I can send messages to classes themselves. That's how I'm going to call my instance, my class method here. That's fun. Oh man. Well, what's the return type of remaining employed? Oh, it's an int. Thank you, interface. So when I go to jump to the definition, look at where it takes me. It takes me to the interface. When I want to go look up how something works, it's just going to give me the signatures of how it works, and later today, our properties of how it works. So I guess the remaining employed gives me an int. The only way for me to see that is to not get a that, but instead I'm going to have to log it out. There are, this is an int. What is the, thank you. What would you call that? Cool. There are %d remaining barkers in our ecosystem. And then I could put this whole statement as an int, because just like with Swift, the whole statement returns an int. So sending this message is the same thing as having a function call returning something in a line. Let's run this. There's 0 barkers remaining in our ecosystem. That is really upsetting. So we're going to take a break, and when we get back in 7 minutes, we're going to create our own barkers and make sure that we keep track of all the hires. So let's come back at 11:28. Yay, Objective-C, we love you.